We're going to be talking gRPC. So from the .NET date from last year, I think we demoed gRPC on App Service Linux. So today we're here back again with more gRPC, and this time showing it on Windows. And Jeff, I don't know if you have the slides ready to go, but this is basically just giving us an opportunity to talk about some of the infrastructure work that we do on the service side, and how that reflects to features and support that we get to present for you, the customers that are ultimately running on this. So this whole thing comes, last year we did some work. This is also one of the cool things is how we use .NET in the service itself. So last year we talked about how we migrated all of the front-end infrastructure. You can think about it as the load balancer that is sitting in front of your application when you're hosting it on App Service, so that you can run on multiple instances and not have to configure some other infrastructure yourself. We migrated all of that from using old IIS HTTP.sys pipeline to using Kestrel and YARP based routing on .NET 6. And that enabled us to then do the gRPC feature on App Service Linux. Now we've done another big platform shift, and that is we've moved all of the Windows-based hosting, what we call the worker VMs, over from Windows Server 2016 to Windows Server 2022. And that's big infrastructure work that happens behind the scenes that hopefully nobody noticed that it happened. But what it means is that we can then go and build additional features, like in this case, the ability to have end-to-end encryption and gRPC for App Service Windows. Jeff, you want to go to the next slide?
Yeah, sure.
Okay, so this is basically a question for you, Jeff. Like, what is gRPC? Why should I care about it?
Yeah, so if you're not familiar with gRPC, it's a remote procedure call created by Google, and it's used for high-performance messaging over an HTTP2 connection. And it does this by opening up a gRPC channel that enables different types of streaming scenarios. So you can stream from the client side, or you can stream messages from the server side, or both at the same time with bidirectional streaming. And because it uses protocol buffers to define the calls, you can also create these language agnostic implementations. So if you want to have a .NET server talk to a Python client or vice versa, as long as you have those protocol definitions on both sides, then you can send those messages.
And usually we contrast and compare gRPC versus REST, right? Those are kind of like the two ends of the spectrum. And why would I choose gRPC over, REST?
Yeah, so REST is more of a text-based approach that communicates over HTTP. It uses the classic request response model, and it opens and closes connections consistently. gRPC uses binaries to communicate over HTTP2. And because of this, you can enable these streaming scenarios. So if you have a lot of data and you need more closer like real-time information, then gRPC is going to be a better option. So if you need that higher performance communication, maybe if streaming is a requirement for you, and also if you have control over both the client and server. So again, if you have those protocol definitions, then that could be your option. REST can be, a better option if you prefer that text-based communication, or if payloads just are less frequent, or if you don't have ownership of the API and you have to communicate through that way.
Cool. So to put it in a nutshell, if the output of the API needs to be human readable, go with REST. If you only control one side of the equation, like you only control the client or you only control the server, go with REST. But if you have those high performance, high throughput scenarios, gRPC is a better option. And if you want to have control both of the server and the client, then gRPC is also a better option. And I think one of the interesting scenarios that comes up a lot these days is, we need to AI all the things. And the canonical example of here's a chatbot, that is not a great scenario for REST, but it's a great scenario for gRPC bidirectional streaming, right?
Yeah, because you're going to have those messages coming in pretty hot, so you'll need that high performance.
Yeah, I think one of the things that comes to my mind is the amount it takes for the, whatever it is you end up calling in the backend for the AI magic. That has an unpredictable delay on how long it will take to get you content back, and also it's unpredictable how big the content is going to be. So when you're thinking from the server side, do I need to chunk this? Do I need to send it in multiple payloads? What is the timeout? All of those things kind of like go away from you as a developer having to build that backend. If you can put it into this streaming bidirectional scenario, right? Because at that point, the client and the server are having their conversation, and results come in as soon as they're there. As opposed to when you're doing REST, you would need to do something like a 201 continuation. You would need to write a bunch of code to handle that async scenario. What happens when it fails? All of that stuff, and you still have the latency of the fact that you're polling, right? So if you miss that response on your previous poll, you're still going to have to wait until your next poll comes around to get data. So that's like a great example of where gRPC is. It's an awesome fit. Okay, what's next?
Yeah, so how does gRPC actually work on App Service? If you're familiar with the Linux version of this, it's going to look pretty much the same. You have to set 3 config settings. One is the version, setting that to 2.0. This is going to actually enable your app to accept these HTTP2 calls. And then you have to set the proxy, which is the second config setting that actually takes the traffic, the HTTP2 traffic, and then forwards it to your application. And then for Windows, you need to also set end-to-end encryption. This is a requirement for gRPC on Windows, as well as App Service. And then, of course,
can we talk a little bit more about the end-to-end encryption? Like today, when I don't have this feature turned on, all of the SSL HTTPS termination happens at the front ends. And then the traffic that's going from the front end to the worker, because it's all within the infrastructure that we provide, is not encrypted. And then the worker itself gets the unencrypted data and therefore processes it. But with gRPC requires it to be encrypted end-to-end, which means that now the SSL processing will need to happen on your worker. So that's a non-obvious impact that you will have when you turn this feature on, right?
Yeah, and so the proxy and the encryption kind of work together to really make it a full end-to-end call.
And you can also use the end-to-end encryption feature even if you're not using gRPC, right? Like those are independent.
Yeah.
Okay, and then on Linux, I know that we support all four scenarios. Is it the same true for Windows?
Yeah, it's the same thing for Windows. Each call, which actually brings us to the next slide, which is the demo. We'll go over the unary call, the client stream, server stream, and the bidirectional stream as well.
Right, and I'm not a gRPC expert. You are the gRPC expert in the house, so you're going to have to explain to me what's the difference between a unary and a client stream, server stream, all of that stuff.
Yeah. So let me share the screen for a second.
So in this scenario, you're going to be showing us 2 different pieces of code, right? One is the server side, and if you remember when we were talking about REST versus gRPC, there also needs to be the client side. So I think as soon as Jeff can get the Visual Studio to share, we're going to start seeing those two things. And I guess also the other question I have is, do I care if I'm deploying it as a Windows source code application or a Windows container? Is it supported for both scenarios?
So right now, Windows Container is not supported. So we'll have to be a Windows code app.
Okay.
Okay.
I'm guessing the plan is, as we get to GA, we get to the point where that is supported as well.
Exactly. Yeah. Okay.
So I'm looks like you have grpc-win.app.azurewebsites.net, and this is just using the browser as the client, and it has that message that tells me, hey, you don't know how to talk to gRPC, so therefore go get a client that does, right?
Yeah, exactly. So this is what we're looking at is the Windows application, the gRPC server that's hosted on App Service. And, as you mentioned, the note says that we need to use a gRPC client to communicate with it. So we're going to pull up our client that we already have created. And with our local client, one thing to note before I run it is that it's pointed to that gRPC endpoint, creating a channel. So let's do a quick run, and we'll make this a little bit bigger for y'all. Okay. So this is just a simple application, a simple console app that just proves that it's making those the calls that we mentioned before. So first call is the unary call, simple request and response method. It's going to happen pretty quickly. It's a single message. The hello part of that string is actually a response from the server that's hosted on App Service.
Okay.
Okay.
And then we're doing this as a console app because it's like real gRPC. If you want to do it from a browser, from like you need to do gRPC web, which is a different protocol.
Oh yeah, you can also host a gRPC. You can host a client application, and then it will still make those gRPC calls to the server on App Service. Okay, so the next one is server streaming, which is a little bit more interesting. And what's happening here is it's sending one request from the client to the server, and then it's actually streaming back the messages. So we're in the background, it's sending a string of those numbers, and then it's adding in the pound sign on the call back to us.
Okay, so if I were doing this with REST, I would need to do one call to initiate the process, and then do a 201 continuation, and then call on that until the server finishes processing and sending me back all of the responses. Whereas here, you just send one request, the request stays open, and then we stream from the server as the server processes, right? The thing that is not evident here from the demo is that the server could be taking, different amount of time in between each one of those responses, but then they just stream back. There's no additional request to call.
Yeah, exactly. So because we established that gRPC connection, which is pointed to the host application, and because we set the proper config on the hosted app, which we'll cover in a second, but the server can then accept the client calls over that HB2 connection, and then it forwards that call to the app, and then it comes back over that single connection with the response. Okay, well, let's go to the next call, which is client streaming. And you'll notice that client streaming acts a little bit different because in the background, it's streaming a string of names to the server, and then it's just coming back as one response. And that's why it took a second for us to see anything. That's all well and good, but I think the most impressive one is the bidirectional streaming. And here we are sending requests and responses simultaneously. The client is sending the string of names, and then at the same time, the responses are the hello part of the string. So it's able to print them out at the same time.
So again, like this is the perfect example for the chat application, right? Where you have communication going back and forth. There's there's processes going on the back end. You don't know how long it's going to take, and you don't have to write all of this logic to account for the polling, the retries, the connection, establishing the connection, reestablishing the connection, etc. So that's kind of like where I think the scenarios shine. We do have a question coming in from Ravi. Let me see if I can pop it up so that we can see it over here. And this is the question about what about gRPC versus WebSockets. So I think this comes down to, WebSockets I don't think are going away, but gRPC is a way to do all of this stuff over HTTP2. I think that is more the question, right? Is HTTP2 versus HTTP1 and WebSockets. And gRPC is just the framework that lets you do that. Hopefully that answers the question.
Yeah, exactly. It kind of depends on what your requirements are.
Awesome. So let's take a look a little bit at the server code and see kind of like what's going on.
Sure. So if we go over to the server code, first I'd like to mention the proto file. This is where you make all of the definitions. So if you go through the process of making a gRPC service for your first time, you're probably going to go to the .NET docs, and this is what I'm using. It's just a templated gRPC server directly from Visual Studio, and then I've just added a few more definitions that include the stream examples. So the server stream, the client stream, and the bidirectional stream. And this proto file needs to be the same in your server code, and then you need to add it to your client as well. Yeah, and then just a quick look at the service that includes the logic for those definitions. You can see here, this is where we're sending back the messages. Unary is the hello, the £sign for the server stream. For the client stream, it's that single message after it takes in the other string with all of the names. And then for bidirectional streaming, go all the way to the bottom here, and then it's that first part, hello, that you're seeing in the demo.
So this really becomes just an async await pattern, and you don't need to handle any of the complexity of the. I think I keep coming back to this. Is the difference between having to write all of that code to handle the continuation pattern on traditional HTTP requests versus just doing async await on a C# project, and the framework kind of like takes care of it for you.
Yeah. And other than that, there's no special thing to do in the program or file or app settings. You can just take it as it is here and deploy it straight to App Service. And then, as we mentioned before, just have those 3 configuration settings in your web app, which I can show.
Oh yeah, so yeah, that's a good point. What you showed us right now is a server, which is what gets deployed to your web app. And then the client application is what's either running locally, or if you have a separate front end, that's where you would have the other gRPC client that is talking to this API.
Yeah. And in your web app, before you deploy to it, you just need to set, again, the version so it can actually take HTTP2 calls, the proxy, again, so it'll forward that traffic, and then the end-to-end encryption. So just those 3 config settings, and then your web app will be ready to accept gRPC calls over HTTP2.
Obviously deploying your code.
Yeah.
We have another question from Ravi as well, which is, will gRPC work over HTTP3 as well? And technically it should. We don't yet support HTTP3 on web apps. It's something that's in the backlog and we want to do, but it's not there today. Okay, so we looked at, what is gRPC, how to do gRPC on top of App Service. We looked at the client, kind of like the different scenarios, what's the value prop. And right now we're at the point where this is in preview, right? So the next step is we're going to take this to GA. Do you have, kind of like what the plan is there?
Yeah, let me go back to sharing the slide. Oh, there it is. Okay, yeah, so there's a couple of limitations that we have currently with gRPC. It only works for in-process scenarios at the moment. So you'll have to keep it on ASP.NET. So your app is going to run, within the same process of your web server.
Mm-hmm.
And we also have site activation also only works with HTTPS. So what we recommend is that you need to keep always on enabled in the config to prevent any scaling issues when only gRPC calls are running, since site activation isn't yet supported with gRPC calls yet. So that's one thing that's coming. Out of process scenarios are going to be supported as well. So your app can run with different web servers. And then we're also bringing Java and Windows Java support and Windows container support. So you can expect that probably later this calendar year.
Awesome. So just to be clear, the Linux side of the house, that is GA, that is across all the different languages that we support, and you have the gRPC activation already there. On the Windows side, you do need to have something that is going to activate the app. That is basically what we call the cold start. That's the first request that comes to your app to have it, come up, start up, and be ready to serve requests. That is, we need that activation to be over HTTP today, and the plan is to take that limitation away so that it can activate over gRPC, so that you can have like 0 HTTP requests to activate the app. And then it only works with ASP.NET today on Windows, but the idea is to also support Java, which is one of the other major languages that we support on App Service Windows. And you mentioned the containers. Then the in-proc versus out-of-proc. What is the benefits of having the out-of-proc part?
Yeah, isolation. That's probably the main benefit. Or if you need to use a different web server like Nginx or Apache.
Okay.
Yeah, and then in proc is you get the performance benefit of running it on the web server.
Right. But then if for whatever reason your process hangs, it hangs the whole web server. So for the scenarios where you might have those hybrid conversations where there's some part of it is HTTP, some part of it is gRPC, that's where you want to potentially separate stuff into out of proc as well. Awesome. After this, what's next, Jeff?
Oh, the last slide is missing. I think this might be the wrong deck.
Okay.
But that's okay. Yeah, so we have all of this, the demo code that we've prepared is on GitHub right now. So you can go and you can clone it and try it yourselves. And then we also have the instructions on there to do all of the config settings for app service.
And just because it's right before build, Jeff and I will be there at build. If you're coming or if you're watching online, we'll have another demo where this is happening as well, and you'll get to see all of the app service announcements that are coming up then. Another shameless plug, we have the app service. If you can't get enough of app service, we have the app service community stand-up that's happening tomorrow, and we're going to be talking about the GA of the automatic scaling, as well as integration with the Azure load testing scenario. So it's all going to be about scale out and perf tomorrow. You can join us. You can find the link on the Azure developers. So if you're on YouTube watching this, that's basically the same thing. And then, finally, you can also reach out to us on Twitter. Haley, I don't know if I was supposed to do this, but I seem to be able to have the option to throw the banners from the community stand-up. That's our Twitter. This is controlled by the product team, so it's actually us answering and posting there. Other than that, I think we're ready for questions. If we have anybody else that wants to ask us something, if not, we can hand it over to the next guys.
Awesome. Y'all are actually our final presentation. We saved the best for last.
Oh, sweet. Well,
Yes.
thanks everybody for hanging out.